Welcome to The Explainer. Today we're taking a pretty fascinating spatial journey right through the architecture of modern cloud security. It turns out, if we map our security defenses directly to the actual flow of data, we get a crystal clear, completely vendor-neutral blueprint of how modern network defense truly works. So let's jump right in.
Okay, let's dive into this. For decades, the absolute gold standard of cybersecurity was the classic castle and moat model. You built a massively strong perimeter, and you just assumed that anything inside that moat was perfectly safe. Well, that assumption of internal trust has completely failed against modern cyber threats. Today, the call is literally coming from inside the house. Attackers exploit weak credentials, they bypass that outer perimeter, and they use lateral movement techniques to just roam freely and access your most sensitive information. So if the castle walls are obsolete, what exactly is the new blueprint for cloud security?
Here's our roadmap for this explainer. 1. The Zero Trust Paradigm. 2. Stopping edge volumetric attacks. 3. Securing north-south external traffic. 4. Controlling east-west internal traffic. And finally, 5. Unified cloud security architecture.
Kicking things off with Section 1, the Zero Trust Paradigm, basically the underlying philosophy of modern security.
Zero Trust architecture is, well, it's exactly what it sounds like. It operates on a really strict mantra of never trust, always verify. Think of it like a high-security government building, where just having a key card at the front door isn't nearly enough. You actually have to swipe your card again at every single room you try to enter. In a modern cloud environment, we can no longer assume safety just because a user or device happens to be connected to the internal corporate network. Instead, you have to continuously validate every single request, regardless of where it's coming from. It completely eliminates the very concept of implicit trust.
You see, true zero trust isn't just a single choke point. It's a comprehensive ecosystem. To actually pull it off, you need a multi-layered approach across 5 core pillars, and all of these pillars absolutely must work together. First up, identity demands strong authentication. Then, devices require continuous compliance monitoring. On top of that, networks need really advanced access controls. Moving a bit deeper, applications and workloads rely heavily on runtime security and strict policies. And finally, the data itself has to be safeguarded. If any single one of these pillars fails, the entire system is put at risk.
And this brilliantly illustrates how the identity and device pillars just have to work perfectly together. It's an absolute necessity. Through solutions like Zero Trust Network Access, or ZTNA, organizations can ensure that only strongly authenticated professionals who are using compliant and verified devices can access specific applications. And the best part? This applies whether they're sitting right there in corporate headquarters or working remotely at a local coffee shop. You're granting access to specific resources, not opening up the entire network.
Now, you might be wondering about the terminology here. It's kind of fascinating how networking relies on this geographic metaphor. And before we look at the specific defense layers, we really need to understand it. North-south traffic refers to data moving in and out, so external users on the internet communicating with your internal applications. East-west traffic, on the other hand, is entirely internal. That's your servers, your applications, and your workloads talking to each other behind the scenes. Grasping this traffic flow is totally essential because you have to apply completely different security measures depending on the direction that data is moving.
Moving on to Section 2, stopping edge volumetric attacks, or stopping DDoS threats. Check out this staggering number, 20 plus terabits per second. That is almost incomprehensible. To put that into perspective, that is like downloading tens of thousands of HD movies in a single second. This metric represents the dedicated defense capacity required to stop today's record-breaking volumetric attacks. Modern distributed denial of service, or DDoS attacks, have reached just incredible scale and sophistication, and attackers don't just use them to take websites offline anymore. They frequently use a massive DDoS attack as a smokescreen to distract your security teams, while they quietly launch multi-layered triple extortion ransomware attacks in the background.
So, how do we combat this massive threat? Well, edge security acts as your very first line of defense. By utilizing these global, high-capacity cloud scrubbing centers, organizations can instantly drop malicious network layer attacks at the absolute edge of the internet. It intercepts all that brute force before it can ever reach or overwhelm your internal data centers. What's most vital here is the goal of zero-second mitigation. With automated, intelligent defenses, providers can neutralize threats instantly. This is a real game-changer for businesses because it ensures your operations stay completely undisrupted. It literally keeps the lights on. Next up is Section 3, securing north-south external traffic. Securing those external communications.
Once we step a bit deeper into the application layer, we hit Web Application and API Protection, or WAP. If you're running any kind of public-facing web app or an online store, this is your primary shield. A WAP solution goes way beyond what a traditional firewall can do. It creates this highly robust adaptive barrier for your entire digital estate. By using machine learning, real-time security intelligence, and advanced automation, it continually updates your defenses to adapt to a rapidly, and I mean rapidly, evolving threat landscape.
Now, what's really interesting about this is that modern north-south defense isn't just about blocking the known bad traffic. Obviously, yes, it protects against the OWASP top 10, SQL injections, and malicious botnets. But a huge part of this defense layer is proactive discovery. It actively uncovers unknown endpoints, analyzes the behavior, and mitigates advanced application layer threats that older traditional static rule sets would just completely miss.
And actually, that discovery element, it's absolutely vital. Why? Because APIs are literally the connective tissue of modern cloud apps, and you absolutely cannot protect what you cannot see. Uncovering neglected, unknown, or so-called shadow APIs across all the different formats, from RESTful to GraphQL, is an absolute necessity. A single shadow API can completely compromise an otherwise perfectly secure system. Having a continuous API inventory ensures that attackers can't exploit some forgotten, unmonitored endpoint as a silent backdoor into your most critical data.
All right, diving into Section 4, Controlling East-West Internal Traffic, the Internal Defense.
Now we're deep inside the network architecture, looking at that east-west traffic. This is where microsegmentation comes into play, and it is a core tenet of the zero-trust model. If an attacker somehow manages to breach your outer perimeter, microsegmentation acts exactly like the internal watertight doors on a submarine. By isolating your workloads and restricting that lateral movement, you contain the blast radius of a breach. You're ensuring that one compromised server doesn't mean the entire network is lost. It's a brilliant, highly effective containment strategy.
Implementing this requires a really critical three-step loop. First, you have to continuously discover and map all of your assets. Second, you use AI to automatically understand the traffic, correlating raw network telemetry into actual business context, which just means you actually understand what the application is trying to do. And finally, you safely generate and enforce segmentation policies. Now, the stakes in Step 3 are incredibly high. If security teams accidentally block the wrong internal traffic, they can literally take down their own company's applications. By leveraging AI to understand that context, security teams know exactly what is safe to block, which entirely prevents that kind of friendly fire.
So the crucial point here is that legacy network segmentation relied on IP addresses. That was clunky and honestly provided very limited granularity. Modern microsegmentation, though, is identity-based and application-aware. For example, you can strictly dictate that a human resources application can only communicate with the HR database and dynamically grant that access based on the role and real-time verification. This automatically and decisively shuts down any unauthorized lateral movement dead in its tracks.
Bringing it all together in Section 5, Unified Cloud Security Architecture, Integrated Cloud Security.
This is where all the puzzle pieces finally lock together. You know, one of the biggest challenges in cybersecurity is the risk of creating technology silos, where each defense layer is just operating completely independently. True zero trust requires integrating these capabilities to give you a unified view of security events. When you seamlessly correlate data across your edge, your north-south, and your east-west defenses, your policies become dynamic. For instance, if your system detects anomalous east-west lateral movement deep inside the network, it can instantly and automatically trigger a revocation of that exact user's north-south access at the perimeter. It's all connected.
Ultimately, by implementing these spatial layers, everything from DDoS mitigation and WAP at the absolute perimeter, down to microsegmentation deep inside, you drastically reduce your risk and shrink your attack surface. So as we wrap up this explainer, I really want to leave you with a question to evaluate your own cloud environment. How much implicit trust still exists in your organizational network today? Thank you so much for joining us on this fascinating journey through modern network defense, and we'll see you next time.